Hello students, so we are gonna study thermodynamics. So let's write thermodynamics. So here in thermodynamics, you can just guess it from the name what we are gonna read this in chapter. Okay, that is thermo means related to heat and dynamics means the pathway the heat is absorbing or emitting. Okay, that means we are gonna what we are gonna study here, that is all about heat absorption and emission. Okay, so that is our thing to study now. Basic concepts of thermodynamics. Okay, so first one is about system and surroundings. This is a very important thing because in every aspects of our thermodynamic properties we are going to come across these two things, system and surroundings. Okay, now to teach you what is these things, let us assume that we have a beaker or jar here. So let us assume there is some water in that. Okay, so here is a lid on that jar or beaker, whatever you say, and here let's assume a burner. Okay, so now if we are gonna heat this beaker or jar, whatever it is, so then some of the water will vaporize and go up, right? So here heat exchange from this part to this part is happening. So in thermodynamics, reaction or the heat exchange were taking place, that part is called system. That means this whole jar or beaker is our system here. Now this jar is not only taking part in this reaction but also what it is doing, that it is emitting some heat outside, right? So except this jar, all the things that is outside of this jar, that will be called our surroundings. Okay, so our system and surroundings we have learned. Now this system is of three types. Okay, that I am going to teach you. It will be very easy. First is our open system. Now in open system, what happens, that I have already told you that in any system, heat exchange can happen or uh, it may not happen. But if it happens, uh, then in some systems, both matter and energy, that means here is heat, can be exchanged between, can be exchanged between system and surroundings. Okay. Now, suppose this lead is not present here. Okay. So, if we heat this beaker again, what will happen? The water will vaporize, right? But here is no lead, right? So the water is not stopping, or the water vapor is not stopping because of the lead. So it will go out, right? So matter of this system is going out, as well as we are heating this jar. So also heat is also going out. So you can see that matter as well as energy is exchanging here between system and surroundings. So it is a open system. Okay. Next, we are gonna see closed system. Okay. Closed system. Now you can just guess it from the name, though I am gonna teach you. That is, here only energy can be exchanged between system and surroundings. So what I have shown you in the very first example to teach you about the system and surroundings, that is exactly happening in the closed system. That is, it is exchanging heat, but because of this lead, it can't exchange the water vapors to outside surroundings. So it is only exchanging energy. So it is called closed system. Okay. Next is our isolated system. Let us see what is that. Isolated system. Now, in isolated system, what happens? That neither energy nor matter is exchanged between the system and the surroundings. Now, how can that be happening? Suppose this jar is painted black, okay, and also some heat resisting paper also be wrapped around it. Okay, let us suppose these heat resisting papers are wrapped around it. So if we heat this jar now, because of the lid, water is not gonna go out, and also because of this black painting and heat resisting paper covering, heat also won't go out. So neither energy nor matter is being exchanged here with the surroundings. So it is here our isolated system. Okay. So here our system is done. Now there is our second matter of discussion, that is our boundary. Okay. So what is boundary? That is, suppose this is a boundary. Okay. And it is, suppose what I told you, that painted black and wrapped with heat resisting papers. So I'm not gonna draw it again, but let us suppose it is happening here. So this boundary, which is the system is facing, so okay, exchange of heat is zero here. So this kind of boundary will be called our adiabatic. Okay, adiabatic boundary. Next is our diathermic boundary. So here heat is being exchanged. Okay, so this kind of boundary where heat is being exchanged, that boundary will be called diathermic. where Q or heat exchange is not equal to 0. Now, there are some properties. Okay, so let us write that properties. The properties are divided into two parts: extensive property, intensive property. Now, what is extensive property? That is, if you uh, add or sum it from outside, you can change it. But in case of intensive property, it is can never be changed, because it is already the internal property of a molecule or a system, so you can change it. So there are many intensive properties, but the trick is there are only 5 of our extensive property. So if we just remember the extensive properties, and all rest of the properties are intensive properties. So if we, in exam the questions come that what is this property, extensive or intensive, so you can just see that if any of those 5 properties are given there or not. If they are given there, so they, that will be extensive. If they are not given there, then that will be obviously intensive property. Okay, so we are gonna just remember 5 extensive properties. That's why what they are, that is mass, volume, that is our mass, volume, then our internal energy, next is our heat capacity. Okay, we are all gonna come across these terms later in this chapter, but just know it now. And then our entropy. Okay, these 5 are the extensive properties. So other than these 5 properties, all are intensive properties. So here properties are also done. Function. So there are two kinds of functions. One is called our state function. Another one is called path function. Okay. Now what is state function and what is path function? State function, this function only depends upon the initial state and final state of the reaction. It is initial state and final state of the system. Okay, not the on the path through which the final state of the system is achieved. But here in path function, it depends on the path through which the final state of system is achieved. Okay, now let us see the first law of thermodynamics, then we are going to discuss all other things. First law of thermodynamics. What does it say? It says that total energy of the universe is always constant. Total energy of the universe is always constant. G can't neither be produced nor destroyed. Okay, only we can transform this energy. Now, for transforming this energy, what we have to do, we go through some certain processes. Our first process is isothermal process. Okay, isothermal process. So from this name, you can just guess that thermal or thermo, that means heat. Heat will be constant because iso, that means iso here and thermal here. That means no change of heat. That so temperature will be constant, or change in the temperature, that is del T equal to will be 0. Next is our isobaric process. Isobaric process. Now, bar means pressure and iso means same. That means pressure will be constant here. So, change in pressure, that is del P equal to 0. Next is our isoporic process. So, poric means volume. So, you can just guess it from the name. If you just remember it from the name, you will never confuse it with other processes. Okay. So, just so I am explaining the names here. So, here volume will be constant. So, del V equal to 0. Now comes the another process, that is called our cyclic process. Now, in the cyclic process, you will found everything, change in everything will be 0, because it is its final state and initial state both are same. Okay. So our last process, that will be our adiabatic process. Okay. So what happens in adiabatic process? Here heat exchange equal to 0. That means del Q equal to 0 here. So that will be our adiabatic processes. Now we have to know about internal energy. So what is internal energy? Internal energy. Now, internal energy is the sum of all kinds of energy in a system. Okay, so let us write it down. Sum of all kinds of energy in a system. That means it can be vibrational, okay, rotational, then your thermal, electrical, anything. Okay, these are force, but if there is other type of energy that is present in a system, that can also be included in internal energy. That will be sum of all kinds of energy in a system. So here we can't conclude the internal energy in a system. We just can measure the change in the internal energy in a system. Okay, change in the internal energy in a system. Now that will we from now on we'll write it as del U. Okay. So from it we can write the mathematical form of the first law of the thermodynamics. I haven't written it previously because you won't understand what will be del U. So I explained the internal energy first. Then I am explaining you the mathematical expression of first law of thermodynamics. Okay. So what will be it? It will be del U equal to Q plus W. Now I have already told you what is del U, and you know Q is heat and W is work done by the system. Okay. So, or the surroundings. So here is one thing that is called sign convention. Okay. So we will just remember one type of sign convention. Okay. So that's why we won't confuse with any other. So let us write it. If heat released by the system, then its sign will be minus Q. Okay. But if heat is given to the system, then it will be plus Q. So from here, you just remember either this or either this. Don't remember two of these because you will confuse. Just remember that whatever happens or whatever you remember, the opposite thing will happen when it will be given to the system. Okay, so just remember the first one. It will be easier that heat released by the system. It will be minus Q. Okay. Now, what about the signs of work done? Let's see that surrounding perform work on the system. So that will be our plus W. Okay. And if system perform work, then that will be minus W. So here also just remember one of them. Okay. So that's why you don't confuse.